Okay, everyone. So today we're going to be talking about two things, and the first new topic for today is the Lechat principle. Now, this deals with that lab we saw last week, and this principle has to do with disturbing an equilibrium. So what's going to happen is that we have an equilibrium, and let me come up with a sample one here maybe. So we have maybe this A solution reacts with this B solution and this C solid to produce maybe this D solution and this E solution. Now because it's an equilibrium, we want to get our double arrow in here. And then the Lechat principle now is all about when we add a stress, or another way to think of it is we disturb an equilibrium. So now what's going to happen when we disturb an equilibrium that had this constant, or this equal rate of the forward reaction and rate of the reverse reaction? The big idea is that the equilibrium in response, it tries to minimize that stress. So to minimize the stress, the big idea is it's going to try and make the opposite occur. So let's look at this little sample reaction. If I add A to this equilibrium, the opposite of add A would be remove A. Now if you want to remove something, you would go away from it. So this would shift to the right then. So our two options now for what's going to happen, you would kind of say shift right. This would mean you're favoring the forward reaction. Now you might be shifting left, and this would mean you're favoring the reverse reaction. And my favorite, and sometimes it's obvious, what's going to happen? Just no shift. You know what's going to happen? No shift. So what happens if I add B? Well, you want to remove B as the opposite, so it would shift right. Now what happens if I take away B? The opposite of take away B is make B, so that means it would shift left. What if I add or remove C? C is a solid again. We're going to get rid of solids and liquids from this equilibrium expression right away. Okay, let's go try some of these practice problems, because I think these will really help illustrate what's going on here. So let's look at this reaction here. I have A gas reacting with B gas to produce C gas and D solid, and it looks like this is an exothermic reaction because that energy term is found on the right side. And we're going to get into the effects of heat here in a minute. So now let's see. If A is removed from this equilibrium, the equilibrium will want to, what's the opposite of remove A? Add A. Therefore, the reaction will shift towards the, now if you want to make more A, you want to shift towards something. So you want to shift left. So shift towards the reverse reaction. It'll shift left. This will cause, now if we're shifting to the left, that's going to make the amounts of A and B to increase. And it's going to cause the, and I'd rather say amounts here than concentrations, because D is technically a solid. Now even though D is a solid, if you're shifting left, you're still going to be using it up. So it's going to cause the amounts of C and D to decrease. And now let's think about energy. If you're moving away from energy, are you going to be making it or using it? So you're going away from it. So that means you are going to use energy, and that may maybe make the temperature go down a little bit for the surroundings. Okay, let's check this next one out. If the pressure, okay, now we need to think about what causes pressure. What causes pressure? Gas. Gas causes pressure. What's the relationship now, let's think about old stuff, between moles of gas and pressure? If you have more moles of gas, would that cause more pressure or less pressure? So more moles equals higher pressure. So let's just remember this. Now, if the pressure is decreased to this equilibrium, the equilibrium will want to, what is the opposite of decreased pressure? Well, to increase pressure is the opposite. Therefore, the reaction will shift towards the, now let's look at this reaction here. How many moles of gas on the left? 2 moles of gas on the left. And now this is a solid. We got rid of that. We have 1 mole of gas on the right. So if you want to increase pressure, would you go towards fewer moles or more moles? Well, you'd go to more moles. So it's going to shift towards the reverse reaction, because moles of gas causes pressure. Now again, this will cause the amounts of A and B to increase because you're going towards them. And I'm going to change this word to the amounts of C and D to decrease. And again, since we're shifting away from it, it would use energy. Now, lastly, if D is added, there is no shift because D is a solid. Okay, so this kind of talked you through what happens. Now let's go through another practice problem here. Using the following chemical equation, describe what will happen if. So if I add N2, what's the opposite of N2 is added? N2 is removed. So you would want to shift right away from it. NH3 is added. What's the opposite of NH3 is added? NH3 is removed. To remove something, you go away from it, so that it would shift left. What's the opposite of pressure is reduced? Uh-oh, I saw that word pressure. I want to count moles of gas. There's 4 moles of gas on the reactant side and only 2 moles of gas on the product side. So the opposite of pressure is reduced is pressure is increased. So you want to go to more moles of gas, so this would also shift left. Now F is a little goofy one. Volume is increased. I want us to think for a second. Volume is increased means pressure is decreased. So first we need to think about this. And then again, now the opposite of pressure decrease is pressure increase, and you shift left. Catalyst. Now we haven't talked about this, but we're going to talk about it now. A catalyst will speed up the chemical reaction, but it's going to speed up both the forward rate and the reverse rate. So there will be no shift when a catalyst is added. What's the opposite of N2 is removed? N2 is added. If you want to add N2, you shift left. Okay, now lastly, let's add this word temperature into here. What's the opposite of temperature is decreased? Temperature is increased. If you want to increase temperature, would you want to move towards energy or away from it? I just want you to think. If you would like to increase temperature, would you walk towards a fire or away from the fire? So when you want to increase temperature, I want you to go towards the energy. So we'd shift right. Okay, let's try 3 more of these. So here, if the temperature is increased to this equilibrium, the equilibrium we want to shift. The opposite of increased temperature is decreased temperature. Since here is my energy, I would want to go away from that. So shift left. Therefore, the reaction will shift towards the, decreased temperature should be here. Decreased temperature, therefore the reaction will shift towards the reverse reaction. This will cause the amounts of A and B to increase, and the amounts of C and D to decrease. This will also use energy or take away energy. Okay, now, reviewing old stuff. We need to think about what delta H 197 means. This means that energy is on the reactant side. So when energy is positive, it's a reactant. Okay, now, how will the reaction shift in order to reach a new equilibrium? Oxygen gas is removed. The opposite of oxygen gas is removed is oxygen gas is added. If you want to add something, you shift right towards it. Increase the volume. Remember that increasing the volume means you decrease pressure. When you see the word pressure, we need to count moles of gas. There are 2 moles on the left, and there are 1, 2, 3 moles on the right. If you want to decrease pressure, you are going to go towards the lower moles of gas. So this would shift left. The opposite of temperature is increased is temperature is decreased. If you want to decrease temperature, you go away from the energy, so you would shift right. And then lastly, the opposite of sulfur dioxide is added, is sulfur dioxide is removed. If you want to remove something, there's our sulfur dioxide, you go away from it, so you shift left. Okay, one more example. Again, delta H negative means the 120 kilojoules is a product. It's an exothermic reaction. How will an equilibrium mixture of these substances in the above reaction shift in response to the following changes? Again, we're trying to minimize that stress by doing the opposite thing. The opposite of add CO2 would be remove CO2. Shift left away from it. The opposite of adding carbon solid, well, we have a solid there, let's get rid of it. No shift. For 3C, increase the temperature. The opposite of increase the temperature would be decrease the temperature. If you want to decrease temperature, you go away from the energy. You go left. Lastly, adding a catalyst is again no shift because that will speed up both the forward and the reverse rate. Okay, now we should read about the Lechat principle in the book and then try those 5 mastering problems I posted. Okay, I hope this video helps and we can talk at the little review session in the afternoon if you still have questions.